Okay, guys, let's review estimating non-perfect squares. So to estimate without using a calculator, it's very important that we know our perfect squares. So I'm going to write the first few at the top. I'm not going to use 1 because 1 doesn't help us with estimating. So we have 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. So the square root of 12, we can see, lies between the square root of 9 and the square root of 16. So we have the square root of 9 is less than the square root of 12, which is less than the square root of 16. So we know that the square root of 12 on the number line comes between 3 and 4. So this is going to be about 3 point something. So to find the decimal part, we first need to write it as a fraction. So from 9 to 12 is a difference of 3, and from 9 to 16 is a difference of 7. So the square root of 12 is about 3 and 3/7, but they want us to write it as a decimal. So we're going to convert 3/7 into a decimal. So it's 3 divided by 7. So the top goes in the box. So we're going to say 7 divided into 3. 7 goes into 30 about 4 times. 7 goes into 20 about 2 times. So I'm going to stop at 0.42. So 3.42 is about the square root of 12. It's just an estimate. It's not exact. The square root of 18, we can see, comes between the square root of 16, which is less than the square root of 18, which is less than the square root of 25. So we know the square root of 18 comes between the whole numbers 4 and 5 on the number line. So it's about 4 point something. Now let's find the fraction and then convert that to our decimal part. So from 16 to 18 is 2, and from 16 to 25 is 9. So 4 and 2/9 we're going to convert into a decimal. So we have the whole number 4. So 2/9, 2 divided by 9, top in the box. 9 goes into 20 about 2 times. And again, 9 goes into 20 about 2 times. So 4.22. And if we're asked to round to the nearest tenth, we would say 3.4 for number 1 and 4.2 for number 2. Now the square root of 24, we can see, comes between the square root of 16, which is less than the square root of 24, which is less than the square root of 25. So we know the square root of 24 comes between the whole number 4 and 5 on the number line. And to get the fraction part, 16 to 24 is the difference of 8, and 16 to 25 is the difference of 9. Let me write these out. And now we need to convert, we have the whole number 4, and now we need to convert 8/9 to the decimal part. 8 divided by 9, top goes in the box. 9 goes into 80 almost 9 times, because if this were 81, but it's not. So we're going to say 8, and then that gives us 72. And then when we subtract that, again, we get, so we're going to say 4.88. And if we were asked around to the 10th, we would say 4.9. Now let's compare this radical 39, radical 39 compared to 34 over 6. So the square root of 39 comes between the square root of 36, which is less than the square root of 39, which is less than the square root of 49. So we know square root of 39 comes between 6 and 7 on the number line. So the fraction part from 36 to 39 is 3. And from 36 to 49 is going to be 13. So the square root of 39 is 6 point something. So let's convert the fraction. So the top goes in the box. So 13 goes into 30 about 2 times. That gives us 26. and about 3 times. So I'm just gonna stop right there. This lets me know that I can just say 6.2. So the square root of 39 is about 6.2. Now let's convert 34 into 6. So 6 divided into 34, top in the box. 6 goes into 34. 5 times 6 is 30. Decimal, subtract. 6 goes into 40, and we could already stop by now, but we'll say 6 times, so it's 5.6. So we can see that 6.2 is greater than 5.6. Therefore, square root of 39 is greater than 3/4 over 6. 34 over 6, excuse me. Okay, now let's compare these two. So top in the box, 3 goes into 17, 5 times, that's 15. Decimal, we subtract, bring down a 0, 3 into 20, almost 7 times, so we'll just say 6. So right now, let's just say this is about 5.6. Square root of 28, we can see up here is between 25 and 36. So the square root of 25 is less than the square root of 28, which is less than the square root of 36. So we know that square root of 25 comes between 5 and 6 on the number line. And from 25 to 28 is 3. So that's 3 over, and 25 to 36 is 11. Let's convert the 3 over 11, top in the box. So that would be 7. So we'd say about 5.3. So 5.6 is greater than 5.3. Okay, now let's take a look and see which of these are rational and irrational. So when you can write a fraction as a ratio where the top and bottom numbers are real numbers, if you can write it as a ratio, then we are going to say it is rational. So this is rational. Square root of 17 is not perfect. It would be a number that kept going on and on. We would not be able to find the denominator because it would never stop. We wouldn't know the place value. So this is going to be irrational. Pi 3.14, it's not really 3.14. It never really comes to an end. This number keeps going on and on. Again, we would never be able to identify the place value. Therefore, we couldn't write it as a ratio. So it's irrational. 8.2, anytime you have a repeating number, repeating starts with R, so that's just a little trick to maybe remember that repeaters are going to be rational because this would be 8 and 2/9. I could write it as a ratio. Number 10, this number keeps going on and on without repeating. We don't know the place value, therefore we couldn't write it as a ratio, so it is irrational. Number 11, negative 7.839. This is a terminating decimal. We do know the place value, so I could say negative 7 and then 839. And this is the tenths, hundredths, and thousandths place. So I could write it as a ratio, so this is rational. Number 12, it is written as a ratio, so we already know it's rational. 13, this is pi, but anytime you have a number over itself, we need to see if we can simplify, which we can. So we have 1, which can be written as a ratio of 1 over 1, so this is rational. The square root of 1, this is a perfect square, so this is 1, and we can write 1 over 1 as a ratio, therefore it is rational. And I hope this helps.